All right, let's dive in. Today, we're taking a close look at one of the most viral and honestly controversial open source projects we've seen in a long time, OpenClaw. This was the tool that promised to give AI a body, to let it actually do things out here in the real world. But in doing so, it kicked off this massive debate about what AI really needs to be, both useful and safe. So let's break down what made OpenClaw so revolutionary and, frankly, so dangerous. This quote from AI researcher Ben Goertzel just hits the nail on the head. It's the whole idea for our explainer today. OpenClaw gives an AI the hands, the power to act, but what about the brain? That distinction is absolutely everything, and we're about to unpack exactly what that means. This thing started as just a weekend project, and then it just exploded. We're talking over 100,000 stars on GitHub and what felt like a blink. The excitement was just off the charts because OpenClaw was different. This wasn't just another chatbot stuck in a browser window. No, this was an AI that could plug into your apps, read your files, and run commands. It was the leap from just talking to actually doing. So here's the game plan for today. First, we're going to look at what OpenClaw promised to be. Then we'll get into that critical hands versus brain idea. From there, we'll see why this whole thing turned into a security nightmare. And then we'll look at a proposed new way to build a complete AI agent. And finally, we'll talk about what this all means for the huge race to build a real artificial mind. So what even is OpenClaw? Let's get into the promise that got everyone so excited and, well, ultimately pretty scared. The project's journey was just wild. It starts out as Claudebot, which is a pretty clever pun on the AI model Claude. Then, after a, let's say, polite legal email from Anthropic, it becomes Moltbot, a name that was apparently picked during a chaotic 5 a.m. Discord session. Just 3 days later, it finally lands on OpenClaw, which really does fit its open source spirit. And all this time, its popularity on GitHub was just blowing up. Okay, so at its heart, think of OpenClaw as a bridge. It's a platform you run on your own computer, right? And it connects a large language model, the AI brain, to your entire digital world. We're talking your files, your browser, your apps, even your command line. And the best part? You could talk to it through apps you already use, like WhatsApp or Discord. Suddenly, the AI wasn't some far-off thing in the cloud. It was your assistant on your machine playing by your rules. And this right here, this brings us to the most important part of this whole conversation. The power of OpenClaw was undeniable. But just because you give an AI powerful hands, that doesn't mean you've given it a thinking mind. And that distinction, well, that's where the real story begins. This slide just lays it out perfectly. On the left side, the hands, that's OpenClaw. It's all the stuff it can do: run commands, read your files, control your browser. These are incredibly powerful, concrete actions. But then you look over at the right side, the brain. This is everything today's large language models are missing. We're talking about real abstract thinking, long-term memory that's flexible, the ability to reason through a problem for more than a few seconds. They're amazing at mimicking, but they don't really get it. So, the bottom line is this. OpenClaw created a system with these incredibly capable hands, but they were attached to a brain that, for all its amazing pattern matching skills, couldn't genuinely understand what it was doing. It can follow a recipe, sure, but it can't invent a new dish. It can't learn from its mistakes and truly grow. And that mismatch, yeah, that's where the trouble starts. So what happens when you give all this power to a system that doesn't have real awareness or built-in safety? You pretty much create the perfect recipe for a security disaster. And this is where the story of OpenClaw takes a much darker turn. You might be wondering, why didn't a company like Google or Microsoft build this? And this quote just explains it perfectly. The big tech companies would never, ever release something so powerful and so risky. The liability is just insane. But in the open source world, people were so excited about what it could do, the thinking was, we'll figure out the security later as a community. But in the meantime, it was a complete minefield. And we're not talking about theoretical risks here. Security firm SmartTech found this massive vulnerability, CVE 2026-2523. In plain English, it was a flaw that let an attacker take complete control of your computer, what we call remote code execution, and all they needed was for you to click one single bad link. So here's how this one-click kill chain actually worked. It's shockingly simple. It starts with a lure. The attacker gets you to click a link. That one click is all it takes to trick OpenClaw into sending your secret key, your token, right back to the attacker. Now they have the keys to the kingdom. They can hijack your session, connect directly to your OpenClaw, turn off every single safety prompt, and just do whatever they want on your computer. It's a total compromise, and it happens in a flash. And believe it or not, it got even worse. The security team at Cisco started digging into the marketplace of third-party skills you could add to OpenClaw. They found one, with the ironic name What Would Elon Do, that had been artificially boosted to the #1 spot. It turns out this super popular skill was straight-up malware. It was quietly sending user data to some random server and using clever tricks to get around the AI safety rules. It shows just how vulnerable the whole ecosystem was. Okay, so the problem is pretty clear, right? You've got powerful hands, a limited brain, and basically no safety net. This is what led researchers like Ben Goertzel to say, okay, we need to go back to the drawing board and propose a whole new way to build these AI agents, an architecture that separates these pieces on purpose. So, first up, you need a dedicated brain. In this new model, this is the component that does all the heavy cognitive lifting, all the stuff that LLMs right now just can't do. It would handle real long-term memory, keep track of goals, build plans, and actually reason things through. The brain's job isn't to do anything. Its job is to decide what needs to be done and, crucially, why. Next, you have the hands, and this is pretty much where OpenClaw's capabilities would fit. The hands component is just the executor. It does exactly what the brain tells it to. It runs the code, writes the file, calls the API. It's still really powerful, but it's not the one in charge anymore. It just takes orders. And this is the most critical new piece, the guardrails. Think of this like a super strict security guard standing between the brain and the hands. It's deterministic, which just means it follows a simple, hard-coded set of rules. The AI can't trick it, it can't talk its way around it, it can't find some clever loophole. If an action is against the rules, it gets blocked. End of story. This is that non-negotiable safety layer that OpenClaw was completely missing. So when you start thinking about this new architecture, you realize this points to the real challenge in AI today. It's not just about building something with more power. It's about actually building a mind. You see, with the brain, hands, and guardrails all working together, you create something called a cognitive flywheel. The agent can act in the world with its hands, it can observe the outcome, and then its brain can learn from that experience and integrate that new knowledge. So with every single cycle, it gets a little bit smarter, a little more capable. This is how you get that compounding, cumulative learning, the kind of learning that our current systems just can't do. Look, if there's one thing to take away from all this, it's this. The story of OpenClaw shows us that the road to truly useful, advanced AI isn't about giving it more powerful hands. The real challenge, the much, much harder challenge, is building a brain that can actually handle that power. A brain that can reason and learn and has safety built into its very core. OpenClaw was a breakthrough. There's no doubt about it. It gave AI a body, the power to act in our world. But it also threw a giant spotlight on the massive gap in our progress. We've built the hands. Now the real race is on to build the mind. And that is a race that's going to define the future of technology and maybe our own.